Hello guys, welcome to Tariq's class. Today we're going to be talking about the topics you need to know for the geometry for SHSAT. So I'm going to be talking about some formulas that you will need for the SHSAT, two-dimensional and three-dimensional, and also some angle relationships with the theorems as well that you will need for the SHSAT. Now let's start with the two-dimensional geometry. First of all, the most famous and easiest one is triangle. So we're going to start with the triangle. How to find the area of a triangle? First of all, A means area, C means circumference, and P means perimeter. So first of all, we have a triangle which has three sides, A, B, and C. Now, and it has a height. This line here is called height because the definition of height is the height has to make 90 degrees with the base. The bottom line is called base. So let's make it a different color. So the red is height and the green one is called base, and they make a 90 degree here. So when the height and base meet, they have to make 90 degree like this, the box. Okay, that's the definition of height. So how do we find the area of a triangle? So first of all, whatever the base is, we're going to multiply base times the height, and we will divide it by 2. That's how we find the area of a triangle. Now let's practice one question quickly so we understand how to do it. So let's say we have a triangle here with a height of 4 and base of 10. Base 10. So how do we find the area of this triangle? So we're going to multiply 4 times 10 divided by 2. So that's 40 divided by 2. That's 20. That's how we find the area of a triangle. Now we have a triangle here. If it's an equilateral triangle, and if they provide the height, they have to draw it like this. And let's say they give you 3, the height, and the base is 4. So what will be the area of this triangle? It will be 3 times 4 divided by 2. 3 times 4 is 12, divided by 2 is 6. That's how we find the area of the triangle. So now, what is this A, B, and C? Now, if you have to find the perimeter, that's when you add the 3 side lengths of the triangle. So you're going to have to add the A with B plus the C to get the perimeter, to add the side lengths of the triangle. That one was easy. Now we're going to learn parallelogram. So how do we find the area of a parallelogram? It's pretty simple. It's base times the height, but not dividing by 2 this time. It's just base times height. So I told you that the definition of height is the height has to make 90 degree with the base. So you can see this is the line that's making 90 degree with the base. So height, base, height, base. So this A here, it's not the height because it's not making 90 degree. It's not 90 degree here. So A is not the height. We know that. So it's base times height. Now let's practice a question right here. So let's say I have a parallelogram with the base 10 and height is 4. So what is the area of this parallelogram? 4 times 10, that's 40. Correct. So that's how we find the area of a parallelogram. Now, how do we find the perimeter? Perimeter of any shape is pretty simple. You just add the side lengths. So I know that this side and this side, they're equal. So if this is A, the opposite side here is also A. If this is B, the opposite from here is also B. So it's just A plus A and B plus B. It's just 2A plus 2B. Simply just add the side lengths of the parallelogram, and the height is not included. Don't include the height. That's how the perimeter works. Now let's go for the parallelogram that's also rectangle. So rectangle is also a parallelogram, but finding a parallelogram, I said base times height, right? And that works for rectangle as well. So we can say the area of a rectangle is also base times height. all the parallelograms, the area is base times height. Now you'll be like, oh, where is base and height? Well, in the case of rectangle, we call the base length as well, and the height we call it width. So we can replace this formula, base times height, with length times width, and that will be the same thing. If you want to find the perimeter, so the opposite of the length is also same, so that's another length, and I have another width. So I have total 2 width and 2 length. So 2 length plus 2 width. Well, obviously the values will be given, and then you just substitute into the formula. Now another parallelogram, which is square, so we can use again base times height, as I said, but in this case the base and height, they're also same, so we can just replace this formula to length times width, or we can also write just any side length power 2. So here in this case the side length is given a, so I'm going to use a, so a power 2. Power 2 means a times a. That's how we find the square. Like for example, if you have a square with side length 5 by 5, all you can do is 5 power 2, that means 5 times 5, that's 25. That's it. That's all I mean. Now finding perimeter, guess how do you find perimeter, guys? You just add the 4 sides. So it's a, this side is a and a, so a plus a plus a plus a, so it's just 4 times the a. So 4 times the side length. These are simple formulas, so it's easy to remember. Now before I go to circle, I'm going to show you something interesting. So let's come to rhombus first. Rhombus is another parallelogram. So the formula is definitely base times height, as I said. What you can do is multiply the base with the height. Now how do we recognize the height? The height has to make 90 degrees. So only place we see 90 degrees is here. So we can call this as height and this as base. So this is the height, this is the base. Okay, guys, be careful about that. And let's draw another parallelogram to make it, rhombus. The difference between rhombus and parallelogram is rhombus has all 4 sides equal. So now let's say this is a rhombus. Now the base here is base, and let's say height here, that's making 90 degrees. That's base times height. That's it. Or it can look like this. If you have the parallelogram and you want to consider this as base, the height will be here. That's height. So either way you will have the same area, base times height. So now one thing interesting about the rhombus and square is, let me show it to you. Now let's say I have a square here, and I said the side length is 6 by 6. What is the area? Yes, it is 36. As I said, 6 power 2, 36, right? That's the side length. Now sometimes what they do is, instead of giving the side length, they will give you, let's keep it this way, I will draw another one. Instead of giving the side length, they will give you this line in the middle. This line is called diagonal when you connect the opposite corners. So this is a diagonal. Alright, so if they give you the diagonal, so let's say diagonal is 5 and they want you to find the area. So this time what you do is, you don't know the side length, so you cannot just do side length power 2, or you cannot do length times width, or you cannot do base times height. So what you can do is, you see the diagonals, a square have 2 diagonals, one on this side, looks a little messy, and I'm going to give them different colors to make it look nice. So this is green, and I'm going to give a red color, let's say. This diagonal here is red. Looks weird, but no worries. Oops. Okay, so this diagonal here is red. So in a square, the 2 diagonals, they are completely equal. So if this diagonal is 5, so this is 5 as well. So the shortcut way is, if you multiply the diagonal number 1 with diagonal number 2 and divide it by 2, that gives you the area of a square. So you don't have to know the side length. If you know the diagonal, still you can find the area of a square. So you can do 5 times 5, because the both diagonals in this case are equal, and divided by 2. So 25 divided by 2, That's 12.5, I guess. Yes. Now practice one more to get better. So let's say I have a square. This is 7 by 7, and then I have another square. This time the diagonal is given, which is 8. So let's find the area of the first square. So 7 times 7 is 49. This you don't need to divide by 2. You don't need to, because we know the side lengths. But in here, instead of side lengths, we know the diagonal. So what we're gonna do is we're gonna multiply the diagonal 1 with diagonal 2. So that's 8 times 8 and divided by 2. So 64 divided by 2, that's 32. So only difference is this dividing by 2. And that is happening because these are diagonals. And diagonals are a little bit longer than the side length. So it's important that we divide by 2 after multiplying them. Now the magic is this works with rhombus as well. Now the rhombus here also have 2 diagonals. One is, let's make it green. This is a little bit longer. The other one is a little bit shorter because these 2 corners are close to each other here. Now I will assign them a value. So let's say the red one is 5 and the green one is a little bit longer, let's say 8. Now how do we find the area? As I said before, base times height is the area of rhombus. That always works unless the height is not given. Like if they give you the base, which is 20, and height is 10, yes, I could just do 20 times 10, that's 200. But in this case, I don't know the height or the base. All I know is the 2 diagonals. So I'm going to use the formula d1 times d2 divided by 2. So 5 times 8 divided by 2, that's 40 divided by 2, 20. So this is a shortcut technique, guys. This formula is rare, but it's a shortcut technique. So we could use it for the square, for rhombus, and one more thing we can use it for is a kite. You guys ever seen a kite? Yes. So the kite also have 2 diagonals. Let's make it longer one red. These are the diagonals. And let's say they give me the value, I will give you the value. They say this is 4 and the red one is 10. So how do you find the area? You multiply the 2 diagonals, 10 times 4, and divide it by 2. So that's 20 again. So for 3 shapes, this formula works. For a kite, or a square, or a rhombus. The formula is d1 times d2 divided by 2. And the d1 stands for the first diagonal, d2 stands for the second diagonal. I will highly recommend, if you don't understand, you can always rewind the video and take a look at it. So far we are at rhombus. So let's fill it up. The second formula that I showed about the square is what? d1 times d2 divided by 2. And also for rhombus, we can do d1 times d2 divided by 2. Well, how do we find the perimeter of a rhombus? There's no big deal. You just add the 4 sides, not the diagonals, not the heights, just the 4 sides. Simply AA. Let's say this is BB. Actually, rhombus has always all sides equal, so I'm going to assign them A as well. So it's just 4A. Yeah. So here B stands for the base. So base in this case could be anything that is making 90 degrees with the height. So now we have a trapezoid. Trapezoid is not a parallelogram because these 2 sides are parallel, but these 2 are not. So it's not a parallelogram. Parallelogram, the opposite sides has to be parallel. So the formula to find the area of the trapezoid is, we're going to call the top one base 1, the bottom one base number 2. We're going to add them. Remember, we're not multiplying, we're adding. So we're going to add them. And then we're going to multiply it by the height. This is the height because that's making 90 degrees. And after multiplying by height, we're going to times it by the height and then divide by 2. So formula is pretty simple. Base 1 plus base 2 times it by height, divide by 2. Let's solve a question. So let's say base 1 is 10, base 2 is 5. height is 4, that has to make 90. So how do I find the area? Guess what? 5 plus 10 times it by 4 divided by 2. That's it. 5 plus 10 is 15. 15 times 4 is 60. Divided by 2 is 30. That's it. Right? Now that's how we find the area of a trapezoid. Now, if you want to find the perimeter, you just add the 4 sides, like this one, this one, this one, and this one, like the borders where the height is not included at all. That's how you find the perimeter. Now, not last but not the least, the circle. This is one of the most important ones. So the circle, before I go on for that, I want to tell you something about the circle. So when you have a circle, the dot in the middle, we call it center. And from this dot, when I draw a line all the way to the circle, the skin, we call it circumference. That's called radius. So this line is called radius. And when you double the radius, let's say this is also a radius, and when you double it, this becomes diameter. Double the radius. So these are the basics of the circle. Now, how do you find the area of a circle? So in a circle, if the radius is given, let's say the radius is 3. So what must be the area of this circle? So we're going to draw pi times the radius power 2. That's the formula to find the area of a circle. Now radius is 3. So how do we find the circle, the area of a circle with radius 3? We can use this. So let's say circle with radius 3, pi times 3 power 2. 3 power 2 means 3 times 3, which is 9, and we put the pi next to it. That's it, 9 pi. Let's solve another question. Let's say we have a circle with radius 4. So it's pi times 4 power 2. So that's 16, and we put the pi next to it. That's it, simple. That's how we find the area of a circle in terms of pi. Now, how do we find the circumference? Circumference is pi times the diameter. You'll be like, oh, what do you mean by that? Let's practice. Now, let's say I have a circle, pardon my circles, and this is a radius, which is 4. As I said, the diameter is just double the radius. So if the radius is 4, diameter is 8. And diameter is what we need to find the circumference. So circumference is equal to pi times the diameter. So as we said, ignore the pi, put the 8 there, the diameter, so it's 8 pi. That's it. Now, if they want you to like literally find the number, then we know that pi means just 3.14. We can just substitute here. So it'll be 3.14 times 8 and whatever you get. So most of the time in SHSAT, they want you to leave it in terms of pi. So that's pretty much it. So as I said, triangle, base times height divided by 2, parallelogram, and then how to find perimeter. You can rewind the videos and watch the part you don't understand. You should take notes, because you will not be able to like maybe memorize it all in one day unless you knew it from before. So break it down in like 2 days, 3 days, part by part, no worries at all. Now let's go for the 3-dimensional geometry. Now this is where the work gets a little bit more, not a lot. So I'll give you a basic idea at first. The geometry shapes, if you want to find the volume, first of all, volume means how much space is inside. Let's say you have a cylindrical cup, like a cup, like obviously, like I have one here. So this is not really cylinder, but yeah. So when you put water in there, so you can find the volume of that water, means how much water can fit in, the space. So whenever you want to find the volume of a shape, any 3D shape, right? There are exceptions, I will talk about it, but this is the basic rule. You'll always do the capital B times 8, H. You'll be like, oh, is it just base times height? No. Capital B stands for area of the base. Area of the base. You'd be like, oh, what do you mean by area of the base? Okay, for example, you have a cylinder. Now, the base is the floor and the ceiling. You can say the base is here a circle. This is a base, and that's another base, right? So area of the base times height. So when we have a circle, can we find area of a circle, guys? Yes, we must need a radius. So let's say the radius of this circle is r, and the height of the cylinder here is called h. So as I said, capital B. So the area of the base in this case would be pi times radius squared. So that's pi r squared. So you write pi r squared times it by the height. So the formula for volume of a cylinder is just pi r squared h. That's how you find the volume of any 3D shapes for now. Now let's say I have a rectangular prism, something like this. All right. Now the base is a rectangle which has a length and a width. So as I said, if you want to find the volume, it's always the capital B, which is area of the base, times the height. Now, what is the area of this base rectangle? It's length times width. So that's the area of the base, length times width. And then you multiply by the height. So times it by height. So that's why the volume formula for the rectangular prism is just simply length times width times height. Area of the base times height. Area of the base times height. That's how it works. Now, let's go back to actually a cube. Let's draw a cube. Well, cube has all the sides same. I'm just going to name them, let's say A, length, width and height same. And the cube, the bottom is a square, as you can see, which has a area A times A. So how do I find the volume? Area of the base times height. Area of the base is what? Exactly A by A, which is A power 2, or A times A, you said. That's the area of the base. And the height itself is also A. So there are three A's. So length times width times height. So when you have three A's time multiplies, you can also call it A power 3. Okay, so that's the volume of the cube. We're going to solve some problems so you get better. Now let's see the volume of the rectangular prism. As I said, the area of the base, which is length times width and times the height. All right, so that's the volume of the rectangular prism. I'm just dealing with the volume. Don't worry about what are these yet. I will tell you later. Now let's deal with the cube. So that's again the bottom A times A, and then height is also A. So we're going to call it A power 3. When they give you a numeric value, a number, all we have to do is just substitute. That's not a big deal. I will explain you how to do that. So, and we did the right circular cylinder, like cylinder. The bottom, the base is pi r squared because that's a circle. Remember area of the base. So capital B times height. So that's pi r squared times height. Pi r squared times height. Okay. So that's for the cylinder. So these are the three. We're going to practice a little bit more before we move on to the next topic. Let's say here. Let's say I have a rectangular solid with the side length 3 by 4 by 5. Well, if you want to find the volume, that's area of the base. That's 3 times 4, 12. Then you have to times it by height as well. Times it by 5. So 60. Now, if we have a cube, so let's say it's 3 by 3 by 3. As I said, volume is area of the base, which is 3 by 3, 3 times 3, times the height, which is 3 again. So 3 times 3 times 3, which is 3 power 3, same thing, which is, what is 3 times 3 times 3? 27. Clear, guys? So these are the three we have done, and we have done some practice with it. Now let's come back for the cone. Now we'll do cone and pyramid at the same time because they are very similar. As I said, guys, how do I find volume of any 3D shape? We do area of the base times height. Now I'm going to change it a little bit. So when it comes to cone or pyramid, what we do is we find the area of the base, times it by height, but at the end we just divide by 3. And this dividing by 3 only works with cone and pyramid. Okay, every other shape they just follow area of the base times height, area of the base times height. But when it comes to cone and pyramid, we have to divide by 3. Okay, now let's say cone is pretty simple. What is the base of the cone? It's a circle. So the capital B, which is area of the base, that's what? Pi r square. And height is just height. Height has to make 90 degrees with the base. So this is height. Guys, remember, this red one, this is not height. Do you know why? Because it doesn't make 90 degrees with this circle. You see, it doesn't make 90 degrees. This is called height. So the one that's this line here is actually called slant height. We call it S. It's not really actual height, it's called slant height. The actual height is in the middle, like this. I'll explain what slant height is. We don't really need it now. All we need is just the regular height. So pi r squared times height, all you have to do is divide it by 3. That's it. Now there's another way to remember this. When you have a cylinder, the volume was what? The area of the base, which is pi r squared times the height, right? Just know that cone is just 1/3 of it. You see 1, 2, 3 fraction. So cone is just 1/3 of the cylinder. So you just can divide the pi r square h by 3 and this becomes cone. Okay? So now let's practice with numbers. Let's say I have a cone. As I said, guys, you have to, if you're getting overwhelmed, you have to pause the video and learn one shape at a time, or until you learn one of them, don't move on. Like, don't go to the next one by one. Take your time, no rush at all. So this is a circle, radius is, let's say, 4 and the height is 6. And how do I find the volume? Area for the base, which is pi times 4 square. That's 16 pi times it by the height 6. So, well, 16 times 6 is 96, looks like. And we just keep the pi there, alright? So that's how we find the volume of the cone. But am I done yet? No. What we have to do is divide it by 3. Remember I told you that's the difference. Pi r squared divided by 3. This dividing by 3 happens with the cone and pyramid. So you're going to get 32 pi. That's the actual volume for the cone. You understood, guys? Don't forget to divide by 3 on cone and pyramid. Now, how does pyramid works then? Pyramid, mostly they test you with the square base pyramid. I'm not really good at drawing a pyramid, but let's see if I can pull it off. Well, the basic pyramid. Now, the base of this pyramid is a square. Let's say it's 4 by 4. The height is in the middle. Height has to be from the middle to 90 degree on the middle of the base. So let's say height is 10. How do you find the volume of this pyramid? As I said, area of the base times height by dividing by 3. So area of the base, this times base is a square, so it's simple. 4 times 4, that's 16. We have to times it by the height, which is 10. And at the end, we'll divide by 3. Okay, I'll just pick the height, make the height as 9. You know, when we divide by 3, it'll be easier to divide. That's why. So let's say divide by 3. Now, we have 16 times the 9 and then divide by 3. When we divide by 3, we can decide to multiply first and then divide, or we can decide to simplify this 9 and 3. So that's just 3 goes into 9 3 times. and this 3 times 16, then we can just multiply 48. That's it. So that's how we find the volume of the pyramid. Let's go back. So as I said, the volume of the cone is just pi r square, right? Pi r square times c by height divided by 3. That's the area of the base times height. You can also call it area of the base times height divided by 3. So when it comes to pyramid, it's also area of the base times height divided by 3. In this case, the base can be square base or it can be triangular base. So you just find the area of the base times height. The square base is what you should know for the SHSAT mainly. Now, that's pretty much it for the volume. Now, what is this SA and LA? I'm going to explain it to you now. When it comes to three-dimensional shape, they have this thing called surface area. Now, for example, if you have a cylinder, oh, I have a nice one, beautiful cylinder, right? So when they put the label here, you see the label for the chocolate. So the label, they put it on the body, top and bottom, there's like some painting. So if you were to paint this cylindrical can, then what would you need? You would need to know the surface area. If you need to know the surface area, then you just use the formula. Now, let me explain what surface area is a little bit more in details. I will start with the rectangular solid. Let's say in the room that you are at, like you want to paint a room. Rectangular solid. Now, a rectangular solid has 6 faces. So we have a floor, we have a roof like a ceiling, and we have walls, one on the left, we have one on the right, and then we have walls on the back and front. So 6 walls. So if I were to find the surface area, I have to find the area of all 6 walls and then add it. So first of all, I want to find the area of the floor and ceiling. So I know that this is length by width, length times width. So if I want to find the area of the floor here, so that's length times width, but I have 2 of them. I have a floor, I have a roof on top, ceiling. So I'm gonna do length times width times it by 2 because I have 2 of them. And plus I have walls. So this wall here, we know that this is a height. So this is width. So width times height. But then I have another wall that's similar to this on the other side. So I do times it by 2. Plus, let's think about the wall in the front. That's length by width. So length times length by height, length times height, but times it by 2 because there is one on the back, like 2 walls. So this is the formula. And once you know the value, you just substitute. This is the formula for the surface area. Let me make it easier for you guys. Let me try to make it. So this formula is pretty simple. All they did is, the length, width, and height. These 3 letters, they made 3 combinations of 2 letters. So LW plus LH plus what remains, WH, and they just put a 2 in front of it. Like for example, if I were to ask you to arrange the 3 letters XYZ in combination of 2, so you could make XY, YZ, what remains, XZ, and just put a 2 in the front. So that's what is happening on the surface area formula. So LWH, length, width, and height, these 3 letters, we are just rotating them around and making the combination of 3 and putting a 2 in front of it. So once you know the formula, it's very easy to just plug in. So let's say we have a rectangular prism with the length 3, width 2, and height 1. So how do you find the surface area? The formula is 2 times LW plus 2 times LH plus 2 times what remains, let's say WH. Yes. So now just substitute. So 2 times length is 3, width is 2, plus 2 times length is 3 and height is 1, plus 2 times width is 2 and height is 1. So that's 3 times 2, 6 times 2, 12, and this 3 times 2, 6, and it's a 4. Watch over my calculation a bit. I may make a mistake. So 12 plus 6 is 18. That's 22 if you add them all. Okay. Yeah, looks like good. All right. So that's how you find the surface area of a rectangular prism. Now, at the same time, I will explain you what is this LA. What does this LA stand for? This one. How do I find LA? So LA means lateral area. It says here in the abbreviation, lateral area. Lateral area means what? Now the lateral area means it does not include the two bases, the top and bottom. So you heard me right. Let's say you want to paint your room, but you want to paint only the 4 walls, not the ceiling, not the floor. That's called lateral area. Let's say for a cylinder, a lateral area is just the body of the cylinder. For example, if you buy a soda can, let's say Sprite or whatever you like, where do they put the label? They put the label on the body of the cylinder. This is the body, right? They don't put the label on top or bottom. How would you be able to open it if that's what they did? Well, if you look at it, it's on this can, see this blue color label they put all around, but the bottom and the top, they didn't put the label. That's called lateral area, just the body, when we do not include the top and bottom. So lateral area means don't include the top and the bottom. So this is just like a normal definition. More professional definition would be excluding the bases, means don't include the bases. So the top and bottom, we also call them bases. Okay, now let's come to the lateral area. What would be the lateral area of the rectangular solid? Now we know that the surface area is, what was it? 2LW plus 2LH plus 2WH, right? That was the surface area of a rectangular solid. Where does this come from? The 2LW represents the bottom and the top, you know, LW, two of them, bottom base and the top base. And these 4 represents the other 4 walls. So as I said, for lateral area, all we do is take the 4 walls. So you can just remove the 2LW and the rest of it is just lateral area. What I mean by that is the lateral area formula is 2LH plus 2WH. That's it. That's your lateral area. How would you solve it? These formulas requires a lot of attention. Like you have to memorize them and write them down a couple times to get better at it. So let's say you have a rectangular solid with side length, 4 by 3 by 2. So if you want to find the lateral area, all you have to do is 2 times, we don't do the bases, it's just the width height plus 2 times height length. So 2 times 3 by 2 plus 2 times height is 2 by length is 4. So that's 6, 12, 16, so 28, I guess, yeah. So that's how we find the lateral area, when we just are interested in the 4 walls, not the 2 bases. So this lateral area, let's find it for the cube. For the cube, let's find the surface area first. The surface area of the cube is pretty simple. Cube has 6 faces and each of the faces are just squares. How do I find the area of a square? It's just a times a. So that's a square. Okay. So for the surface area of a cube would be just 6 times, because there are 6 faces, 6 squares, and each square is a power 2. So it's just 6 times a square. That's the surface area. Now guess what's going to be lateral area? So lateral area does not include the top square and the bottom one, only the 4 walls. So it will be 4 times a square. Remember that in a cube, on a cube, each and every face is a square which has an area a power 2. Means a times a, length times width. That's how we find the area of a square. Now that's for the cube. And once they give you the values, all you do is just substitute. So how about the lateral area of a right circular cylinder? First, let's find the surface area of a cylinder. Well, cylinder has 2 circles. Remember, surface area means I want to paint the cylinder. So I'm going to start painting the circles. Let's say the first circle is pi r square. Where am I getting it from? Because that's the area of a circle, pi r square. And I have 2 of these, so I'm going to write 2 times pi r square. How do I have 2? One on the bottom, and one on the top. And that's the top and bottom. So let's say if I tell you to paint the cylinder and you just paint the top one and the bottom one and bring it to me. So I'll be like, oh, you made a mistake. You have to paint the whole cylinder. I said the body of the cylinder as well. You'll be like, oh, I don't know the formula for the surface area of the body of the cylinder. So I will tell you now. So if you want to find the cylinder body, you have to remember this formula. It's 2 pi r h. 2 pi r h. 2 times pi times r times h. Okay? Now it probably sounds difficult to you. Let's make it easy. As I said, take it easy, no rush, one shape at a time. Learn the volume of it, lateral area and surface area. Memorize the formulas, write it a couple times, and then you'll see it gets easier. Now, let's say I was talking about the cylinder. As I said, the surface area was 2 times the pi r square because of the 2 circles plus 2 pi r h. Now, they give you the radius, let's say 5, and height is 3, and you need to find the surface area. So 2 times pi is just there, not bothering at all, and radius is 5 power 2. So that's 25 times 250 pi, right? Plus 2 times I have a pi times the radius is 5 times the height is 3. So 5 times 2 10, 10 times 3 30. So you put 30 pi, total 80 pi. So that's the surface area of a cylinder. Now what will be the lateral area of a cylinder? Remember I told you the lateral area means we don't count the top or the bottom, just the body. So the top and the bottom were the 2 circles, right? So which was like 2 pi. So we're going to remove these 2 circles. So the lateral area is just 2 pi r h. So that's the formula for lateral area, just 2 pi r h, which would be just this 30 pi. Okay, you guys understanding the lateral area? Alright, good. So now more practice will be needed just to get very good at it. I'll take you there, don't worry. Now just the lateral area is what? 2 pi r h. You guys are probably following. Remember before, for rectangular solid, the surface area takes all the faces. Lateral area takes only the 4 walls. When it came to the cube, surface area takes all 6 faces. Lateral area takes only 4 faces. When it came to the cylinder, surface area took the top and bottom circles plus the body. Lateral area took only the body. When it comes to cone, it will be the same thing. Surface area takes everything. But cone has only one circle. That's pi r square. You know, circle is pi r square. And how do I find the body of the cone? It looks like a cone, which is a cone actually. So how do I find the body of a cone? The surface area means if you were to paint the cone, then you have to use this formula, pi times r times s, pi r s. The s stands for the slant height. Okay, let's practice it with a question. You'll feel better. Let's say we have a cone with a radius 5, right? And the height is 10. And the slant height, let's say I'll pick much nicer numbers. I don't need this height to find the surface area, but I'll just do it. So let's say radius is 3, height is 4, and the slant height is 5. Now if you want to find the surface area, it's pi r square for the circle plus pi r s. This is something you have to remember, pi r s, like pi r s. Now just substitute. The radius of this cone is 3, the circle on the bottom, plus pi times radius is again 3, and this time we're using the slant height. We don't care about the actual height. Slant height, which is 5. Remember this, guys. 3 power 2 is 9 pi, plus 3 times 5 is 15 pi. So that's 24 pi, I guess. Yes. Right? Yeah, 24 pi. That's the surface area. But if you want to find the lateral area, remember, we do not take the base. Guess what's the formula for lateral area then? You're right. Just pi r s. Just pi r s. Lateral area is equal to just pi r s. Simple. Because we don't take the circle, pi r square. We only take pi r s. So that's pi times the radius is 3 times the 5. So 15 pi is just the lateral area. That's it. Now, what you have to do is memorize this part for the lateral area. This is pi r s. So interesting part is the body of the cylinder is 2 pi r h, that's the lateral area, and it's part of the surface area as well. The body of the cone is pi r s, and it's part of the surface area as well. So lateral area is part of the surface area. Technically, the surface area is equal to lateral area plus the basis. Okay. Now, let's come to pyramid. How do I find the surface area of a pyramid? That's pretty easy. A pyramid has a square base. So you're just going to find the area of the square base. So surface area, you're going to find area of square base plus there are 4 triangles. Remember, surface area means you're painting the pyramid. So you're going to need to find the 4 triangles. That's how you find the surface area. So what will be the lateral area, guys? Guess what? Yes, just the 4 triangles. Remember, the area of 4 triangles, not just. So just the area of the 4 triangles. That's how we find the lateral area. I hope you're understanding the difference between the lateral area and surface area by now. So let's practice one for the pyramid with a number. So as I said, I'm not good at drawing pyramid probably. Alright, so let's say this is a square base which is 4 by 4 and the height is 5. Let's say not 5. Well, we are interested into the triangle. Let's say this is the triangle on the side. So the height of that triangle is 5. Not the full shape. Height of the triangle is 5. Now if you want to find the surface area, first thing you need is find the area of the square, which is 4 times 4. That's 16. That's the area of the square. Plus, we need to find area of the triangle, which is 4 by 5. Do you guys remember how to find the area of a triangle? Base times height divided by 2. So you're going to do 4 times 5 divided by 2. So 4 times 5 is 20, divided by 2 is 10. So, but 10 is the area of one triangle. There are 4 of them. So you're going to times it by 4. So that's 40. So total surface area is 16 plus 40, 56. Let's explain it a little bit better. So the surface area is area of the square plus triangles, 4 of them. So area of the square was 16 plus the 4 triangles square area was 40. That's how I got 56. Now guess what will be the lateral area? Lateral area, we do not need the area of the square. It's gonna be just the 4 triangles. So the lateral area is just 40. That's it. That's how it works. So surface area, lateral area, complete. So the surface area formula is here, lateral area is here. So now let's just review what we have done. I have given all the formulas here together, so nicely written, and you can take a look at it, study more, and you'll be fine. These are the 3D shape. Like pause and study. Remember one thing, every height has to make 90 degrees with the base, as I said, and the volume for every prism is base times height, area of the base times height, but the cone and the pyramid were different. You had to divide it by 3. Now all you have to do is study. First understand the formulas and then study. This is a quiz where I left it blank for you to practice. After memorizing the formulas, just practice from these worksheets. Like take a look and try to write down the formulas on your notebook. Alright, these are the 3D shapes. Pause the video, learn them. There is no rush. Alright, now I'm going to start the second topic of the day, the angle relationship. Okay, why it is doing this? Alright, now here. So for geometry for SHSAT, angle relationships and theorem. So here I'm going to teach you how to name the angles, supplementary angles, complementary angles, vertical angles, sum of the interior, Pythagorean theorem, isosceles triangle, triangle inequality, alternate interior angles, and properties of parallelogram. These are pretty simple. So let's take you to the first step, is how to name angles. That's very important part, guys. Naming angles. We name angles using 3 letters. So let's say I have a triangle here, ABC. It has 3 angles. Now if I ask you, how do you name this angle here, the red one? You are going to say angle B, but that's not how we name angles all the time. So we use 3 letters. So I'm going to draw 3 lines. The angle is on B, letter B. So I'm going to write that in the middle. Okay. And then the other 2 letters A and C that is coming and connecting to the point B, we're going to put it on the 2 sides. So the name of this angle is angle ABC. This is just the angle symbol, angle ABC. That's how we call the angles. Let's learn it a little bit more. Make sure you guys take notes. Pause the video if you need more help. So I'm gonna just draw a couple more things like this. Yeah. So just to make it look nice, let's say this is another triangle here. So I assign them letters A, B, C, D, E, F, G, H, I, and J. And I tell you what is the name of this angle here. You're going to draw 3 lines. The angle is on point E. So E goes in the middle. And the other 2 points that are coming and connecting to E is F and J. They're the one coming and connecting to point E. So I'm going to just write F and J here. Doesn't matter the order. So the name of this angle is angle FEJ or JEF. Okay, so that's how you name the angles. Now let's try one more. How would you name this angle here? You see the A is going to be in the middle and the B and C coming to join at A. So you just put it here. So angle BAC. How would you name this one here? Guess what goes in the middle? Yes, C. And you see that this point D coming to the C and E. So D and E on the 2 sides. You getting it, guys? So how do you name this one? This point here. Let's make it green like this one here. So it's on letter I. So that goes in middle. And you see the F and H. They're coming towards the I and connecting here to make the angle. So you put F and H. That's how we name angles, by using 3 letters. Okay, now the second, it's called supplementary angles. So when you have 2 angles, they add up to 180. That's called supplementary. That's called supplementary. So when you have a straight line, we also like learned straight lines on this. A straight line, and if you start from a point of the straight line and go back to the line itself, they make 180 degrees. So this is called 180 degree. So if I split this 180 degree and I call this angle here is 60 degree, so what is the angle next to it? It's 180 minus 60 is what? 120, because 120 plus 60 will be 180. This is called supplementary when they add up to 180. Let's practice it a little bit more. So let's say I have a straight line and I'm splitting it into two this time. So let's say this is 60, this is 90, then how much is this angle here? So well, 90 plus 60 is what? 150, right? So this angle must be 30. So that all of these angles make 180 degrees, because that's what the supplementary is for, right? Add up to 180 and the straight line. Clear, guys? So that comes on the test. Now let's say complementary angle means it's similar to the supplementary, but this is add up to 90 degree. Like for example, this is a 90 degree angle. If I make a split, call this angle 30 degree, what is the angle next to it? It's 60 degree. So 60 plus 30 is 90. Let's practice another one. Very simple this is. If I split, let's say this is 40 degree, how much is the angle next to it? This one, 50, because they have to add up to be 90. Okay, one way to remember which one is 180 and which one is 90 is by their spelling. Let's say supplementary looks like this, right? And the complementary looks like this. Sorry. Now, as you can see, the supplementary, the S, turn it into 8, this into 0 and put a 1. So that's 180. And the complementary, the C, turn it into a 9, and that's a 90 degree. So it's just an easy way to remember. Once upon a time, one of my students taught this method. So I liked it, so I show it to everybody. So now, what is the vertical angles? Vertical angles, when two lines intersect, like X. So then they create couple angles, like angle here and here. The ones across from each other, they're equal. So if this angle is 60 degree, the angle across from this is also 60 degree. And the one here, this angle and this angle, the two red, they're also equal. So if two lines intersect or make an X, then the opposite angles are equal. Now the angles across from each other. So if this is 120, that's 120, that's it. That's vertical angle. Now sum of interior angles of a polygon. Now polygon means a shape that's more than two sides, like triangles, quadrilaterals, pentagon, heptagon, hexagon, those. So let's say a triangle has three sides and three angles in it. And you know the three angles of a triangle, no matter how big the triangle or no matter how small the triangles, the three angles always add up to 180 degree. The three angles always add up to 180 degree. Even if I make the triangle huge, still. For example, if this is 40 degree, this is 60 degree, so 60 plus 40 is 80, and I subtract from 180, that's 100, that's gonna be the third angle. Okay, now when it comes to a quadrilateral, means four-sided shape, it can be parallelogram, trapezoid, square, anything. It has four angles, not three anymore, it has four. In a quadrilateral, the four angles add up to 360 degree. Means if I say this is 120, this is 60, 120, 60. So all four will be add up to 360. Now, when it comes to a pentagon, then there are five angles. What do the five angles add up to become? What about hexagon? The 6 angles, 7 angles, 8 angles. We don't want to memorize all of these. So we use this formula, which is called n minus 2 times by 180 degree. Okay, n minus 2 times it by 180 degree. You'll be like, oh, what do you mean by this formula? Why you are teaching me this? Okay, let me explain you why. If you have a triangle with 3 angles, right? So n stands for the number of angles. So triangle has 3. So I'm going to put 3 here. 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 is 180. That's why the sum of the 3 angles of a triangle is 180 degree. Okay, let's try with the quadrilateral I said. So the 4 angles add up to 360, right? If we use the formula n minus 2 times 180, so 4 minus 2 times 180, so 4 minus 2 is 2 times 180 is 360. Now don't worry about why we're subtracting 2 and why it is n minus 2 times 180. Don't worry about it, you don't need to know that. Just follow the formula, substitute. Then a pentagon has 5 sides. So guess, how do I find the total number of sides for the pentagon? I mean the sum of the 5 angles. Let's draw the 5 angles first. Just like rainbow. 1, 2, 3, 4, 5, right? So what is the sum of these 5 angles? So we can use the formula n minus 2 times 180. N stands for the number of angles. A pentagon has 5 angles. So 5 times 2 times 180. So 180 times 3, that's 540. And if you want to find how much is each one of these angles, you just divide that 540 by 5 and then you will get 108. That's each. Alright, so n minus 2 times 180, this formula is very important. Learn it, very important. Now next thing guys, these theorems is a lot to understand in one day. I would say break it down, learn part by part, go with your own pace, like whatever is your level, no need to rush. So Pythagorean theorem works with the right triangle only. This theorem is the babyest theorem ever, like very basic. A squared plus b squared equal to c squared. You know, A, B, C. Probably these are the 3 letters you said in your life when you were born the first time. Let's say the mommy is like, oh, say mommy, you said A, B, C, right? So A squared plus B squared equal to C squared. So it's very easy to remember this formula. So the point is, the C is the line that's across from 90 degree, guys. This is C. A and B, you can switch around, doesn't matter. You can call this A, call this B, or you can call this B and this A. Doesn't matter. But the C has to be across from 90 degree because C is the longest line of the right triangle. You see, it's pretty long. So C has to be across from 90. Like kids make mistakes on that all the time. No matter how many times I say it, some of them always make that mistake. So be careful. See, the C matters the most. So let's practice one question. Yeah. So let's say I have a triangle here with the side length 3 by 4 and I don't know this side. So as I said, A, B and C. So A is, let's say 3, B is 4 and C is missing X. So I'm going to use this into the formula. A squared plus B squared equal to C squared. Square means power 2, guys, okay? So A is 3 power 2 plus 4 power 2 equal to X power 2. What is X? I don't know yet. Now 3 power 2 is 9 plus 4 power 2 is 16 equal to X power 2. So that's 25 equal to X power 2. Well, the last step of Pythagorean theorem is always a square root. Square root, okay? Square root of 25 is 5. So X equal to 5. Okay, the square root. Square root is just opposite of square. So, you know, square root of 36 would be 6. The reason we do it is because there is a power 2 on the X. And we do the inverse operation. Let's practice more. Let's have a triangle. And I want to know this time this. So what is our A? A is X, let's say. B is 6 and C is 10 this time, guys. C is across from 90 degrees. All right. So you're gonna get x squared plus 6 squared equal to 10 squared. So x squared plus 36 equal to 100. Now you know how to solve one-step equations. Just minus 36 both sides. So x squared equal to 64. And the last step is always square root. Square root. So x equal to 8. That's it. That's how you find the missing length of a right triangle. I'll give you one more and you try it on your own. Let's say here. So let's say this side is x, this is 12, and this is 13. So how are you gonna do it? X squared plus 12 squared, or 12 squared plus x squared, doesn't matter. But the 13 is the C, guys. Okay. 144 equal to 169. You should know these perfect squares. Turns out to be nice. So 9 minus 4 is 5. 25. So square root is square root, x equal to 5. That's it. That's how we find missing length of the Pythagorean right triangles. Now I'm going to talk about what is an isosceles triangle. Guys, as I said, take it easy, no rush, go with your own pace. If it's already a lot, the Pythagorean theorem or whatever we learned, pause it, learn it, then move on. Now isosceles triangle means it has two sides that are equal. You see the triangle? How many sides equal? Two sides. Two sides are equal. And two angles as well. Now, you see the two sides I drew line? This side is equal to this side. You see, this is the point they both meet. The both green lines coming and meeting at this point. So this angle at that point here is called vertex angle, their meeting point. And the other two angles, the leftover ones, they're called base angles. Base. So in an isosceles triangle, two sides are equal and the base angles are equal. What do I mean by that? Let's practice. So they play around with this a lot. So if I say this line here, the purple, let's name it ABC. I say BC is equal to AC. So BC and AC are equal. So which two angles are equal? So first of all, BC and AC, they both meet at point C. So this point C is the vertex angle. So the base angle must be what? A and B. So angle, remember I told you angles are named with three letters. So how do you name angle this one? So A goes in middle, so BC. And how do you name this angle? B goes in the middle, AC. So BAC and ABC, these are the two angles that are equal. So how to deal with them when they give you numbers? Let's say I give you a triangle ABC. I say AB is equal to BC. So AB is this one and BC is this one. Now I give you this angle here is 70. How much is this angle A? Now first of all, you see AB and BC meet at this point. So this is their meeting point. So that's the vertex angle. So the other two are the base. And we know that the base angles are equal. And three angles of a triangle always add up to 180. So we do 180 minus the 70. So we have 110. So what do we do with this 110? We divide it by 2. You are right. So we get each one of these base angles are going to be 55 and 55. That's it. Now number 8, triangle inequality theorem. Well, this is actually a very funny theorem. Let's learn it. If I have a triangle, let's call them ABC, the three length. The theorem says if you add two sides of a triangle, let's say A and B, it has to be greater than the third side C. If you add A and C, it has to be greater than B. If you add B and C, it has to be greater than A. So this is true for every triangle in the world. Every triangle. You were like, what do you mean by that? Let's practice. let's say I have a triangle, side length 3, 4, and 5, and I'm saying, is this triangle possible or not? So you have to check it. What is 4 plus 3? 7. Is that greater than 5? Yes. Now let's check the other two. What is 4 plus 5? 9. Is that greater than 3? Yes. Now let's check the other. What is 5 plus 3? 8. Is that greater than 4? Yes. So this is a good triangle. Yes. Good triangle. You'll be like, oh, what is a bad triangle then? Which one doesn't work? Now let's say I have a triangle. Can you have a triangle with the side length 1, 2, and 3? Let's check it. So 2 plus 3 is 5. That's greater than 1. That's okay. 3 plus 1 is 4. That's greater than 2. That's good. 1 plus 2 is 3. Is that greater than 3? No, there is a problem here. This is not right. So no, you cannot have this triangle. What is the logic behind it? Let me tell you. If I give you 3 toothpicks, like one is this small, another one is a little bit small, and another one is big, and I tell you to make a triangle with these 3 toothpicks, can you make it? So you'll be like, all right, I'll put it like the big one on the bottom and the small ones here. See, you cannot make the triangle. These 2 points cannot connect. Why? Because the 2 sides are too small. So if I give you instead 2 sides that are add up to be longer than the third side, then we can make it. Let's say the 2 long sides, I'll put it like this, and the baby one here. So that's the logic. So any 2 sides in a triangle, if you add anywhere in the world, the sum means the total has to be greater than the third side. Remember this. Now number 9. As I said, take it easy, guys. Don't push yourself too hard. Once you understand the topic, that's when you move on. These are like, I literally put almost everything you need to know for this test. So alternate interior angles. So when you have 2 parallel lines, right? And this only works with the parallel lines. And if I draw a line, you see in the middle, let's draw it with a different line. So you can make a Z in it. Let's use the rainbow color. Z. See the Z here? So when you make a Z like that, the 2 angles here and here, they're equal. This only happens with the parallel line. Okay? We also can use the Z other way around. So this angle here is equal to that, and this here is equal to this. You'll be like, oh, what do you mean by that? Let's practice a little bit more. So 2 line, another line cutting. This line that is cutting, it's called transversal. Alright, so do they make a Z here? Yes, there is a Z here. So this angle is equal to this. Is there another Z? Yes. Here. This Z. Here. So this is equal to that. So that's called alternate interior angle. You can also call them Z method. So let's deal with the numbers. So if I say this angle here is 60, I know that according to the Z, this angle here is also 60. That's it. Nothing else. Very small deal. Not hard. Well, the last one is the properties of parallelogram. How to deal with that. Because there is some things you need to know about parallelogram. Very simple. When you have a parallelogram, the angles across from each other, they're equal. Means if this is 60, that's 60. That's it. And the one here, let's say this is 120, and the other one is also 120. So that's all I wanted to say about the parallelogram. That's pretty much it, guys. For SHSAT geometry, it's not big topics, they're small topics. So give some time to understand the formulas, and you can be like, oh, Tariq, I studied for 5 minutes and I don't get it. Well, because it's just 5 minutes, it's not gonna work. So you have to put more time in it. Go backward, rewind the video, take nice and beautiful notes, make flashcards, write down the formulas a couple of times. understand what is the volume, lateral area, surface area, and memorize the formulas like it's flowing through your blood. And then substitution. And practicing, you can practice more questions. You can find those questions online, or I have my book, as I always say. You can get it from Amazon or Tariq, Bobby Tariq, store.bobbytariq.com. You can also find it there. I hope this was helpful, guys. If anything, any question, you can put it on the comment section. And as I said, I put everything together to take it slow, no rush at all. We have now still time for studying, depending on when you watch this video. Thank you very much, guys. Have a great day, and put some comments and let me know what is the problem. And I hope you learned something. Thank you very much, guys. Have a great day.